Hello, my name is Dave Morgan, and today I'll be discussing the new Windows 7 features of Applocker and VHD support, in addition to the Windows Gadget GPU meter. The first feature we're going to be discussing is Applocker. Applocker builds on a foundation that software restriction policy created way back in Windows XP and has continued on through Windows 7 and was also supported in Server 2003 and 2008. Applocker is only available in Enterprise or Ultimate editions of Windows 7 currently, and much like software restriction policy, is managed in group policy. What's a little different about the way Applocker functions is it does rely on the application identity service to be active on a Windows 7 machine. That is not something that by default starts when the computer starts. It is something that you have to manually start unless you change that setting. This is actually a good feature because when you're first setting up Applocker, should you happen to break or misconfigure rules and it causes your computer to be unstable or function improperly, all you have to do is restart your computer. The application identity service will be off again, and you can go back to trying to figure out how to make all the rules work correctly. Applocker also does have a fallback block rule, so once you do start to configure Applocker, it is good to get all your rules into place because its default behavior, if you don't configure something, is to block any sort of program. A couple of the advantages to using Applocker. The first is it does have the ability to be applied to specific users or groups of users. This is a little bit different than the way software restriction policies function. It can be applied to all future versions of an application. This is not the case in all the rules that are out there, but it does have that ability, which puts it way above what software restriction policies can do. And you can automatically configure rules now. Applocker now has wizards that allow you to easily configure rules and hopefully get them a lot more accurate than having to kind of feel your way through in software restriction policy. And the last thing is the interaction of the rules is a lot more logical when it comes to the way Applocker functions as opposed to software restriction policy. Software restriction policy has a bit of a strange interaction with its rules in that there's a hierarchy for which rules will trump which other rules. What that means is you may deny a certain program from running in one rule and not realize that another rule allows it. Well, in Applocker, what it will do is automatically block it if you've got a block in place. And in software restriction policy, if the allow rule is actually a higher ranking rule, it will allow that program. So the interaction can get a little funny in software restriction policy. You don't have that issue with Applocker, and that kind of moves Applocker to the more logical flow that most Windows and really security and most computer applications follow, which is denies will trump allows. Now just to touch on some of the rules for controlling files in Applocker. The first is an executable rule. This controls the .exe and .com files. This is obviously the most commonly configured rule because it controls most of the programs you're going to run on a computer. Most of those are going to have .exe or .com files that are going to be the programs that run. You also have Windows installer rules. This covers .msi and .msp files. These are your Windows update files, Windows installer files. This is actually really nice because in Applocker you can give users the ability to install and update their computer with certain Windows packages, and you don't have to give them administrator rights on their computer, assuming you have all the rules configured correctly permissions-wise. You also have script rules, covers a lot of different script files that are out there, just controls whether or not the users are allowed to run scripts and where. And you also have DLL rules, again, just much like the MSI or I'm sorry, .exe files, controls how things run. You also have a different set of rules in Applocker that Applocker actually uses to identify which files it's going to apply the rules to. The first one's a hash rule. This is identical to what is used in software restriction policy. Basically, Applocker runs a little computer algorithm on the program you're looking to block. It generates a long string of numbers that is the fingerprint of that program, and then knows every time it runs, it checks against that fingerprint, goes, should I block this, should I allow it, and knows what to do with it. The only issue with hash rules is they are version specific and program specific. So if the program is modified in any way, if it's updated, if it's patched, any of those behaviors will throw the rules out the window and immediately break them. So if you have an issue where an update may slip through without you knowing about it, you could have a lot of users who all of a sudden can't use programs. You also have path rules. These are the easiest to create and understand. Basically all this is, if a program's running out of a specific folder, that's how it identifies what it should do with it. They're also the easiest to break, unfortunately, because all you have to do is have that program moved out of the folder or rename the folder, and all of a sudden it can't identify it anymore. Last ones are publisher rules. This is new to Applocker, and this is where you get the forward thinking in Applocker, where it can actually learn to update itself when it comes to a file or a program being updated. So basically it uses a certificate to then identify the program, as opposed to a fingerprint algorithm. And that way it is not specific to that update or that version. It will move forward as the program is patched or updated. A couple of little things about how Applocker, how you configure it and how you understand how to make the rules work. The first thing is auditing in Applocker. It is something that you can turn on when you're actually creating the rules. It's an option that's there. It's a great thing to do. In fact, it's best practice is to test it under an auditing policy first, and basically what that'll do is, instead of actually blocking the rule or blocking the program or allowing the program, it will write into the event log what it would have done and a couple other things. And what it does write is the rule name, the rule that was applied, the SID of the user or the group, and that's just identifies who the rule was going to be applied to, which file the rule would affect, so again how it identifies the program itself, whether it would have blocked it or allowed it, and then the type of rule, so if it was a .exe or whatever. The next feature we're going to discuss is virtual hard drive support. There are a couple options with VHDs in Windows 7. You can create them. What that just means is you simply create a VHD file. You create a file with a .vhd extension on the end of it that then functions and acts like a separate hard disk in Windows 7. You can mount a VHD. Basically all that means is you're attaching it, you're attaching that file into your operating system, and from here on out until you unmount it, Windows 7 will look at it like a standalone normal hard drive, even though it's just a file. And both creating and mounting are available in all editions of Windows 7. The last function you can perform with a VHD is booting to a VHD, and this makes it even more like a normal typical hard drive. Dual boot and multiple boot options are also available in all editions of Windows, and this is just simply you have Windows 7 running on your computer. You can then have a VHD running a Linux version, another Windows version, whatever it may be. There's also native boot. This is something that's only available in the Enterprise and Ultimate editions of Windows 7. And what that means is you can literally boot the computer from a VHD file with no other operating systems present on the computer. So in essence, you are booting the computer from a file with nothing there to look at it. And that's a really nice feature. There are a couple of types of VHDs that are out there. The first one's a fixed size. What this means is that when you set the VHD up from the creation point, it is the same size. It's always the same size. It doesn't matter how much information, how little or how much is in there. It's always going to be whatever you set it to be. So if you set it to be 40 gigabytes and you have 4 megabytes of information in there, it still takes up 40 gigabytes of space on your hard drive. That's obviously the downside. The upside is it does give the best performance of any of the VHD options. The next one is dynamically expanding. This is probably more common, especially when it comes to student and testing applications, because it is just as big as you need it to be, up to a max size that you also set. Again, it grows with the amount of information you put in there. So the upside is it saves space. The downside is it does give a little bit of a performance hit to run this way. In addition, it can cause errors because it takes a snapshot of how much space is left on that hard drive when you initially create the VHD. If later down the road you don't have that much space left and the VHD grows past the amount of space that's left on the hard drive, you'll start to get a lot of errors, write errors, and the VHD is not really smart enough to catch on to the fact that it's too big for its space. The last type is differencing, and this is somewhat unique in that effectively it's a two-drive relationship. You have a parent drive, which is your ideal, what you're going to take a snapshot of and run everything off of that. So the parent's going to be read-only, and it then interacts with the child drive, and that the child drive only holds differences between it and the parent disk. So generally the child is going to be dynamically expanding as well. So that gets bigger the more changes and the more differences it has to the parent. The nice thing about this is it does flow into what you can use it for, which is a pretty big deal, and something a lot of people are looking at now, which is user-specific hard disks. In Windows, for a long time, you've had your own login, you've had your own settings, you've had your own home folders. What this actually gives an administrator the ability to do is they can set up a differencing VHD off of their ideal for each user on a computer they share. So basically, not only are the permissions isolated, all the files are isolated as well, all the changes that user's made. And yeah, just from a common sense standpoint, that's going to isolate the users even more. It's going to create even less of a security issue. It's almost like the user plugs their own hard drive in every time they log on to a computer. It's also quicker for software rollouts. So instead of having to create a Windows image file, a WIM file, and have to continuously update it and package all the applications you want in there, you can create a VHD, in essence a hard drive, with all the applications and the new software and whatnot that you want to roll out, and just roll out basically a hard drive instead of a WIM file that you then have to copy and push down and have every computer install. With a VHD, you just turn it on and you start running it. The last one is it's a lot easier for testing and trials. This is something I have personal experience with. Tested Linux and also Windows 8 were both on VHDs that you could download. So there's a lot less setup. You don't have to worry about necessarily running them in a virtual machine or anything like that. You just install the VHD file, download the VHD file, mount the VHD file, and then you have access to the software. And since you can boot to it, you can then use a dual boot or triple boot and actually have it on your real hardware. And the last thing we're going to touch on today is the Windows gadget of GPU meter. It's a pretty simple gadget that is great for tuners and gamers. Because what it does allow you to do is actually see the real-time performance of your graphics card, which is great because you can actually see how it functions on the programs you like to run. So when you have that program running and it's doing something that's really intense that you think may be a problem with your your graphics card, you can actually look over there to your gadget and see how the graphics card is behaving. The only downside really to this is that the gadget only supports certain versions of the two most common graphics cards, but it's a wide range in both of those graphics cards. So other than that, it's a great little product. Again, I'd just like to thank you for taking the time to listen to this presentation, and it was on the new Windows 7 features of Applocker and VHD support, also with the Windows Gadget GPU meter. Thank you.